Next, we move the section towards right and take it towards left of B and very near to it. So shear force towards left of B is equal to, we see that there is no force acting between these two sections. So this is same as WL by 3. Next we take section towards right of B and very near to it. So shear force towards right of B is equal to, we see that there is an addition of this small amount of force due to the UDL W acting for a very small distance between point B and this section. So neglecting it, we have shear force towards right of B same as that of shear force towards left of B. Next we move the section towards point C and taking section towards left of C and very near to it. Shear force towards left of C is equal to, considering the left hand side of section, we have there is an addition of this downward UDL of intensity W Newton per meter acting for a span of L by 3. So we can assume a point load of magnitude W into L by 3. So we have WL by 3, which is this value, minus WL by 3. So this is equal to 0. So with this, our shear force calculation is over. Let us plot the shear force variation diagram. So we see shear force towards right of A is WL by 3. So let us plot a positive shear force of WL by 3 at point A by taking proper scale, and let us connect it with the zero line of a shear force diagram. Now shear force towards left of B is WL by 3, as well as shear force towards right of B is WL by 3. So let us plot a shear force of plus WL by 3 at point B. Now between point A and B there is no load acting, so the variation of shear force between two will be 0. So let us connect point A and B by means of horizontal straight line. Now shear force towards left of C is 0. So let us plot a 0 shear force at point C. Now between point B and C we see that there is a uniformly distributed load. So the variation of shear force between point B and C will be linear. So let us connect it with an inclined straight line. With this, our shear force diagram is complete. We see the whole of the beam is subjected to positive shear force. Now let us start bending moment calculation. A sign convention for bending moment calculation is clockwise moment on the left hand side of section and anti-clockwise moment on the right hand side of section is taken as positive. Anti-clockwise moment on the left hand side of section and clockwise moment on the right hand side of section is taken as negative. So again we take point A as origin and we move towards other extreme end point C. Now we see that at point A there is a couple of moment acting. So let us take a section towards right of A and very near to it. So bending moment towards right of A is equal to, considering the left hand side of section, we see that there is an anti-clockwise moment MA whose magnitude is 5WL square by 18. So we have minus 5WL square by 18 plus there is a clockwise moment caused due to this vertical support reaction VA acting at a very small distance from this section. So we can neglect this moment. So bending moment towards right of A is only this much value. Next we take section at point B. So bending moment at point B is equal to, considering the left hand side of section, we see that there is an anti-clockwise moment MA plus now there will be a clockwise moment caused due to this vertical support reaction VA acting at a distance of 2L by 3 from point B. So we have plus WL by 3 into 2L by 3. So this is equal to minus WL square by 18. Next we take section at point C. Bending moment at point C is equal to 0, since we know that summation of all moment about any point, and if that point is 0 and if that point is C, is equal to 0. Now since C is at extreme right end, summation of all the moment about point C is nothing but sum of all the moments considering the left hand side of the section from point C, which by definition is nothing but bending moment at C. Now since summation of all moments about point C is equal to 0, bending moment at point C is also equal to 0. So with this, our bending moment calculation is over. Let us now plot the bending moment variation diagram. So we see that bending moment towards the right of A is minus 5 WL square by 18. So let us plot a bending moment of value minus 5 WL square by 18 by using proper scale. Let us connect with the zero line of bending moment diagram by straight vertical line. Next we see bending moment at point B is minus WL square by 18. So at point B, let us plot minus WL square by 18 bending moment. Now we see that between point A and B there is no load, so the variation of bending moment will be linear. So let us connect it by an inclined straight line. Next, bending moment at point C is 0. So let us plot 0 bending moment at point C. Now between point B and C there is uniformly distributed load, so variation of bending moment between point B and C will be parabolic. So with this, a bending moment diagram is complete. We see that whole of the beam is under negative bending moment. So with this, our problem is over. Thanks for watching in 5 minutes.